Okay, so today we're launching a deep dive into a really grim piece of history, Napoleon's 1812 campaign in Russia. We want to look beyond the battles, straight into the catastrophe of human loss itself.
It's hard to even grasp the scale.
Mhm.
The Grande Armée, it marched in with, what, 500,000 men? Maybe more, up to 600,000.
Huge numbers, and the survival rate was just abysmal, an 80, maybe 85% loss rate.
Yeah, and this is really the crucial thing. Most of those deaths, perhaps over 300,000, they weren't actually from fighting the Russians.
Right, it was the environment. Cold, starvation, and disease, especially disease.
Exactly. And for 2 centuries, the story was pretty much set, based on accounts from doctors back then, like J.R.L. de Kirchhoff. He described symptoms, fever, weakness, stomach problems, generalized stuff. So the long-standing assumption, the main infectious killer, was typhus.
Typhus, okay. Camp fever. Makes sense, given what they knew then. But it was always a bit fuzzy, right? Based on symptoms that could be many things.
Precisely. An educated guess. But now, fast forward 200 years, and we have this incredible forensic science, paleogenomics. And it's completely flipped the script on that old diagnosis.
So how did that happen? Where did the breakthrough evidence actually come from?
Well, it actually started by accident. Back in 2001, in Vilnius, Lithuania, there was construction work going on, and they unearthed this huge mass grave.
A mass grave from Napoleon's army.
Yeah, over 3,000 soldiers piled together. Vilnius was a critical point during that disastrous retreat, remember?
Wow, 3,000. And the archaeology itself told a story, didn't it?
It did. They found uniform buttons, confirming they were Napoleon's men. But crucially, almost no signs of battlefield trauma. No knife wounds, no bullet holes to speak of.
So they weren't dying in combat there. It points straight back to exposure, starvation, and disease.
Exactly. Which brings us to the molecular detective work to figure out which diseases researchers needed, well, basically a biological time capsule.
And they found that where in the bones?
In the teeth, actually. Specifically, intact teeth. This is super important because earlier studies, maybe using less specific PCR methods, often had problems with contamination or degraded DNA.
Okay.
But the dental pulp, you see the soft tissue deep inside the tooth with all the blood vessels, it's incredibly well protected. It seals off the microbial DNA from the environment.
Ah, I see. So it preserves the DNA of whatever pathogens were actually circulating in their blood right before they died. Ancient DNA or aDNA.
That's the one. It provides a much more reliable snapshot of the infections they were battling.
Very clever. Rigorous. So what did this high-tech analysis actually find? Did it confirm the old typhus idea?
Well, here's where it gets really interesting. Killer number one, identified in 4 soldiers, wasn't typhus. It was paratyphoid fever.
Paratyphoid, caused by salmonella, right?
Salmonella enterica, paratyphisi to be exact. It's an enteric disease, waterborne, spread, fecal-oral route, which just screams.
Complete breakdown of sanitation, hygiene gone out the window in a desperate retreat.
Totally. And here's an amazing link back to the history. Remember Dr. Kirchhoff's notes from 1812?
Vaguely, yeah. What did he say?
He specifically noted that widespread, severe diarrhea broke out after the starving, dehydrated soldiers started eating salted beets, baraki cuisson they called them, and even drinking the salty pickling juice because they were so thirsty.
Oh, wow. So that could have been it. A mass transmission event right there. They're trying to survive, get some fluid, some calories.
And instead, they potentially dosed themselves with salmonella, an acute dehydrator hitting an already weakened, dehydrated army. Lethal.
Just devastating. But you said killer number one. Was there more?
There was. The team also detected evidence of a second major player, relapsing fever.
Relapsing fever. What causes that?
It's caused by a bacterium called Borrelia recurrentis. And significantly, it's louse-borne, spread by body lice.
Ah, so that fits the camp fever profile a bit better, like typhus was thought to be. How did relapsing fever contribute specifically to the disaster in the Russian winter?
It causes these horrible cycles of high fever, chills, muscle pain. You get intensely sick, maybe feel slightly better, then bam, another wave hits you. It's incredibly debilitating.
So it would just immobilize soldiers. Even if they had a bit of fight left, a fever spike would pin them down.
Exactly. Makes them completely unable to march, to find shelter, to even try and keep warm. In that environment, being immobilized for even a day or two by fever, that was a death sentence from exposure alone.
And the most powerful evidence of just how bad things were.
One poor soul tested positive for both, paratyphoid fever and relapsing fever at the same time.
Co-infection. Wow. So they weren't just fighting one invisible enemy, they were being overwhelmed by a cocktail of them.
A microbial cocktail, absolutely. And bringing it back to the historical revision, this rigorous aDNA analysis found no reliable genetic traces of the classic suspect, Rickettsia prowazekii.
The typhus bug. So does that mean typhus played no role at all? Or just maybe wasn't the dominant killer here in this group?
That's the critical distinction, yeah. Based on this evidence from the Vilnius grave, it wasn't the main culprit we always assumed it was. It seems the stage was set by the brutal cold and starvation, which just tanked their immune systems.
Suppressed everything. Made them vulnerable.
Right. Then paratyphoid delivers the acute dehydrating blow, and relapsing fever pins them down, ensuring they succumb to the elements or the combined infections. It's a synergistic nightmare.
So this study is powerful not just for finding these specific bacteria, but for giving molecular proof to those vague historical observations. Like Kirchhoff's note about the beets and the diarrhea. It adds this whole other layer.
It really does. It shows how paleogenomics can directly interrogate these historical mysteries and revise long-held beliefs that were based purely on symptom descriptions.
Absolutely fascinating. A real game changer for understanding that campaign.
But it also leaves us with a final thought, something for you, the listener, to consider. While we now have solid evidence for these two major killers, paratyphoid and relapsing fever, remember, this comes from testing just a handful of the thousands of bodies found in Vilnius.
Right. It's a small sample size of a huge tragedy.
Exactly. So to really understand the full picture, the complete spectrum of diseases that shattered Napoleon's Grande Armée, we'd need to analyze many, many more of those remains. There could still be other microbial enemies waiting to be identified in that frozen ground.